Let's have another look at samples. The purpose of a sample is to glean information about a population from a small group of individuals from that population. So we want to know about what is happening in the population on the left without looking at it by looking at the few individuals or the randomly selected individuals we have on the right. But is a sample meaningful? Is there a point where we can say that we've seen enough individuals in order to glean something about the population or the bigger picture? So let's look at this hidden picture, and let's take a small sample. If we just take that sample out of the corner, you would think that the entire picture looked black if we extended that sample and information from that sample over the whole picture. If we took at the top, we can see that's something quite different again. That's got some blue in it and some sort of fuzzy white stuff. Perhaps seagulls or something like that, but hard to know. Perhaps it's an ocean sea. And we look down again, and it's black with maybe some sort of wall in it. And we take another larger sample, and here we see something that appears to be the back of a ship. But can we really be sure that it's the back of the ship? So we'll finally take a larger sample, and this larger sample is actually large enough for us to glean something about the entire picture or the entire population, not of planes but the entire visual population or the picture, to get an idea of what the big picture is about by looking at a smaller part of it, but not too small. So we can probably predict what the rest of the picture looks like now. And if we look at the rest of the picture, we see it's 2 warships, 1 aircraft carrier, and 1 that is in fact just a small warship with ocean and sky. So that final sample was good enough to make some predictions about the actual population. So let's look at 2 samples from 2 populations, and we see that we have 2 that look fairly similar. The mean, median, and the median and upper and lower quartile are highlighted in blue and green and red. And when you put them onto box and whisker graphs, you can see that they look very, very similar. But the real question is, are they actually? The samples are very similar, but are the populations similar? Can we be sure that this is true? So let's go and have a look at the actual populations. And there we see the 2 populations, and the population 1 has a median 3, upper and lower quartile the same, but a slightly extended range now, whereas the bottom one is quite different. The median has gone up from 3 to 4, the upper quartile is now 5 and the lower quartile is 3, and the range is much, much bigger. So if you can see that the sample tells us something a little bit different, second one at least, from the population. The first one didn't. So that's one of the problems with sampling. Yes, a small sample might provide you with good information, or it might not. So let's have a look at the actual sample and the actual population graphs. And you'll see here that a sample of population 1 and the actual population 1 are quite similar, but sample 2 and the actual population of 2 are quite different. So we need to develop some systems to work out, well, what is sufficient sample size? Does the sample tell us something about the population? Can we be confident that the information in the sample actually tells us something about the population that's meaningful? So even in the first example here, we can't really be confident because it's a small sample that the actual population is going to look the same, even though it does. And the second one, when we look at the actual population, we see it's quite different. So these are questions that we're going to ask. We're going to look at samples. We're going to be able to say, well, is the information in a sample sufficient to tell us something meaningful? And then we're going to look at differences in population. Are 2 samples from 2 different populations different, or are they similar?